class stuff, which for the next 3 classes, which I think is most of the remaining class, it's going to be all Windows. Windows is the most important target, and it's the most complicated. Yeah, good hustle if it works. Yeah, I know. The thing about NFTs is I imagine it's just a bubble, and the value will fall. Stream is really bad for you. Oh, is it? I thought it got better since I restarted it. Stream is fine. Yep, let me know. Try refreshing your browser. That might help. I have to do that a couple times in each lecture. Anyway, let me know. I appreciate the feedback. I'll try to change things if I can. So we're down to Chapter 12, Investigating Windows Systems, and I've got some slides where here they are. Good. File, Open Recent. There it is, 12A. All right, and this thing is moving all right now that I'm connected with a hardwire. It's going to give me this font garbage again. Apple seems to have nuked some font, and so it makes me say this for everything I've got. All right, anyway. All right, that's looking pretty good. All right, so we're the first part of investigating Windows systems. This time we're going to talk about the NTFS file system, the Prefetch folder, event logs, and scheduled tasks. These are just Windows features that are important for forensic analysis and incident response. And in the next 2 lectures, it's going to be the registry, a whole lecture just on that, and then other artifacts like memory forensics and persistence mechanisms. So these are all features of Windows that you need to understand. So NTFS is the file system. A file system is a way to organize files on a disk, so you store the file name and the owner and the timestamp and other information like permissions about a file, and you keep track of what folder it's in, and you tell that those blocks are in use so they don't get overwritten by other blocks. And there are dozens of file systems in use in the world, but in the world of Windows there are only 2. There was FAT, that was used by MS-DOS, Windows 95, and Windows 98. And when Microsoft made Windows NT, they made the new file system, NTFS, and that's it. They planned on developing some others, but they never really developed them. There's one called ReFS that is for a sort of RAID-like fault-redundant volume only for servers. You'd never see it on a client machine. But they promised others and got partway through developing them, just abandoned them, and just stuck with NTFS. NTFS has been the standard since 1993, which is a pretty long time in the world of computers. There have been version upgrades, but nothing major has changed. So NTFS has replaced the file allocation table from MS-DOS with this larger object called the master file table. And this is what stores the metadata about your files: the name, the owner, permissions, and where to find the blocks on the disk. So this is any file that is an active file has an entry in the master file table. If you delete a file, then its entry in the master file table is removed eventually, and then it becomes unused space. And we talked about this. A forensic tool can recover the data of those files, but it won't be able to recover the metadata like the owner and the timestamps, because that is in the master file table. So here you've got timestamps, the size of the file, permissions, parent directory, contents, all the directory information about the file. Each NTFS volume has its own master file table. It's stored in the volume root as a special file starting with a $sign, so it's not shown to a normal user coming in through Windows Explorer looking at the root of C or anything. It's not, you have to have raw disk access. It's not stored on a partition. It's stored outside the partitions because your users are not supposed to be reading or modifying those files or deleting them or anything. They're supposed to be beyond your reach. They're for the system to control the disk. And so you can see it in Velociraptor. And we've done this before. If you go to the file directory in Velociraptor, you see these files here. And here's the master file table. And here's other things like the log file, the boot area, the bitmap, the recycle bin. All these are the system files that are used to do essential housekeeping, and the user is not supposed to touch those files directly. The user does things like right-click and make a new file, and that creates an entry in the MFT, but the user doesn't directly touch the MFT. So you've got a series of records that are 1024 bytes each, and you have one for each file and one for each directory. The first 16 entries are essential things like the MFT itself, the log file and more. You saw the first 16 files on the disk are these dollars files, and WinHash is a Windows tool that will let you see these things. The same stuff you see in Velociraptor, it just accesses the disk directly, and so you see the MFT. And the MFT mirror, by the way, there are 2 copies of the MFT maintained, so if one gets corrupted, you can recover at the other one. And there's a log file and a boot file, and then you can have other files down there. All right. So in there, you've got a record number and a parent record number, a flag telling whether it's active or inactive. If you delete a file, the record is marked inactive, and then other attributes, metadata like permissions and timestamps and such. And here's the attributes. The standard information is here, and then the file name, and then the data. So the standard information is the ordinary timestamp and such. The file name is here, and this is where you can store some data up to several hundred bytes. And so you can get them in Velociraptor. You can use NTFS MFT, and that will parse the MFT data and show you the MFT records. And you can hunt through the MFT records to find files. And then you can even hunt through the MFT records to find inactive records, which are files that have been deleted, but they still have a record in the MFT. So you can recover those files, and you will recover the metadata as well, if their record in the MFT has not been overwritten and is still sitting there inactive. So that sounded great, and I tried to make a project where I used it, and it didn't work. And then I realized from here, this is why. The problem is the MFT is efficient. So if the operating system creates a new file for any reason, the first thing it does is reuse inactive MFT records. And the operating system is constantly creating new files with background processes, creating log entries and stuff. So if you do delete a file, very soon, within a few seconds or minutes, the operating system wipes out that metadata. So that recovery feature doesn't work very often. And that's the problem. Anyway, so when I tried to make a project where you would delete something and then recover it with a Velociraptor, and it didn't work very well. And I said, well, I can't really assign that. It doesn't work. Now, you can recover with any forensic tool like NCASE or FTK or SleuthKit. You can recover the contents of a file in the clusters because those will sit there for a really long time, but you won't get the metadata unless it has been a very brief time since it was deleted. All right, there's 4 timestamps on Windows System. There's actually even more than this. Modified, accessed, created, and entry modified. And it's going to have 2 whole sets of these attributes. One for the standard information and another one in the file name. So there actually are 8 timestamps in there. Now, if you just open the properties in the Windows Explorer and you see some stuff here like created, modified, and accessed times, those are the standard information timestamps, which are the only thing you can see through the Windows operating system directly. And all right, that's the normal thing. The entry modified is not visible here. You can get it from forensic tools. So they call it the MACE timestamp: modified, accessed, created, and entry modified. These are the 4 kinds of timestamps in a file. But they're a lot less useful than you might think they are. The access timestamp is no longer updated anymore in modern versions of Windows, and even if you enable it, which is not enabled by default, it can be off by an hour. So it's not worth a whole lot. The second set of 4 timestamps in the file name record refer to the entry for the file name. And so, by the way, another horrible thing about internal Windows is it's really still using the old 8.3 DOS file names. I don't know if you guys are old enough to have used MS-DOS, but in MS-DOS, the file name could only be 8 letters long, then there had to be a dot, and there could be an extension that could be no longer than 3 letters. And that was a hard limit. So you learned to use strange abbreviations to cram everything into 8 characters, and inside the operating system, it still uses the short file name. And the long file name is sort of an optional thing that is not always implemented for a file. So there are some command line commands that will refer to files by the old 8.3 name. I see somebody says -1. Well, anyway. All right, so time stomping is what a hacker will do that wants to hide timestamps. Because, of course, if you hack into a system and then you hit the antivirus, you set off the intrusion detection system, then people start instant response, and they will take the time when that alert came and they will look for events near that time. So if you could move all your created files to a different time, then you could hide from them. So what you do is use a program that does time stomping, and typically what you do is you pick a time like the time they installed the system. You go to C Windows System 32 and look at those files. Those were put there when they installed the system, or they have timestamps that came from when Microsoft finalized their golden image of Windows. So you can just make your timestamp equal to that time, and then your files will appear to be innocent system files, at least as far as the time. So you can modify the time, but a lot of these tools are not very effective. So programs running in Windows can only change the SI timestamps, the standard information. They can't change the file name timestamps, but there is a hacking tool called setMACE that can alter them all. So if they use a sloppy procedure, then they might result in changing some of the timestamps, but not all of them. And now you can identify that by seeing inconsistency. So here's the standard information timestamps, and here's the file name timestamps. And somebody time-stomped this file, so the standard information claims to be 2006, but the file name claims to come from 2009. So that is a clue that someone has manipulated these timestamps. All right, and by the way, there's these SANS posters you can get to put on the wall that list all these artifacts in Windows. And when I used to teach the first forensics course, we spent a lot of time going through this, but now it's a whole lot easier because it's all just there in Velociraptor. You just have to remember the general categories that are there. Like I say, Velociraptor has made this course a lot easier. In fact, this whole instant response course has gotten a lot easier as the tools get more powerful. So let's try a Kahoot. In earlier versions of this course, we installed an awful lot of Linux utilities that were hard to install. Here, we're doing very little of that. So 12A1 is here. All right. Giving Bobcat. That looks like a joke I don't know. Well, there might be only 4 competitors. I'll give it a few more seconds. All right. We will charge ahead regardless. All right. So where are the normal timestamps you see in a property sheet? All right. Oh, you typed in spooky season and it gave you a weird nickname. That's cool. Anyway, standard information. Good. All right, what item replaces the FAT table in the modern file system? The MFT. Good. And which timestamp is no longer updated? Okay, that's accessed. Good. And which timestamp is not visible? Okay, that's entry modified. All right, and so I don't know who that is. 0. Clayton looks like a real name. And this, I think, is Twisted. Giving Bobcat is Twisted, right? Yep, okay. All right, so 0 is not getting their points unless they come out of the closet, but they may not care. All right. So let's move ahead. All right, so data runs. Well, I used to have projects where you actually go manually fix a data run, and it's pretty tedious. So data has a list of the clusters in the contents, and it goes cluster to cluster hopping along, and most files are not broken. So it starts at cluster 1009 and it goes to cluster 1021 or something, and all those clusters are just nicely in the line, and that's your file. But sometimes, because of deleting and such, you get files that are fragmented, where part of it is here, and then part of it is there, and part of it is here, and the pieces have to be put together. That's non-contiguous. And this lists all the data runs that have to be reassembled. Then there's resident data. If you have a small file, like a notepad file with just a few sentences in it, it might be only a few hundred bytes. And in that case, you don't need to store it out in the clusters on the disk at all. You can store it right in the master file table. Remember, there's 1,024 bytes for each file, and it's not really using very much of that for things like the file name and the metadata. There's 700 or 800 bytes left, so it just puts it right in the master file table. And the data is right there. That's called a resident file. It does not have a data run. It does not go out to the clusters on the disk. So this means the MFT may have Slack space left over from the contents of previous resident files. That 700 or 800 bytes of unused stuff might have contents from a previous file. So it's like everything else. It's not a complete, well, it might even be a complete file, I suppose. Anyway, I don't know how often that is, but it's a possibility. You might find something in there. Another form of Slack space. Then there's alternate data streams. We talked about this before. One file name can point to 2 or more streams of data. And so you have unique runs of clusters, and they all have the same standard information and file name and timestamps, but they have multiple cluster numbers. They're pointing to different data runs coming from the same source. And you've seen this before. You can echo data into a file, and then you can echo into that file : another name, and now you have 2 data runs coming, two data streams tied to the same file. And as a student pointed out last time when we were talking about this, one that is commonly used is zone identifier. If you download a file, the operating system puts a second data run on it, a second data stream, to mark the zone identifier to say this file came from the internet, and then when you try to run it or use it, it will pop up a box and say, this file came from the internet, are you sure you want to use it? And it records that information within the alternate data stream. All right. And so here I downloaded iTunes, and if you want to see the data stream, you can do dir/r in modern versions of Windows, and then it shows you there's iTunes setup.exe, and here's iTunes setup : zone identifier data. And before Directory had this property, there was a sysinternals tool, and it's still out there, called streams. Streams will let you see the alternate data streams also. All right. And there are tools just to analyze the master file table. You can acquire it, and then you can feed it into a tool that will let you see it. SleuthKit and the forensic suites will, of course, do it. And there are other ones like Analyze, MFT, and Plaso that will reconstruct the evidence inside the master file table. And there's an index attribute in the master file table that has an index of files. And one thing interesting about that for forensic analysis is that when files are deleted, the index often contains metadata anyway. Some of the metadata is preserved there, like the timestamps and the file name, even for deleted files, because even though the primary record containing the file name was marked available and then reused, the index doesn't seem to clear up so fast, or maybe not at all. The index record will just be preserved. All right. So that's 12A2. And I got to go to favorites to clean it up. There we are. And 12A2 is right here. Okay. All right. Spooky season. How'd you find that out? Must have found it on Twitter or something, huh? Oh, just a random guess, really? Oh. Well, I'm surprised. Maybe there's a lot of things that it will replace by other things. Classy Ibex 48. That looks like the result of spooky season. Well, you're finding the hidden meta keywords in Kahoot. Ah, all right. We got 4 people, and they look like different people. So I'll wait and see if we got any more. Aha, we might, yeah. All right. Give it a few more seconds. All right. All right, so which one of these is 1 kilobyte? That's a master file table entry. That's how much room you have to store all the metadata about your file. All right, which one lists the clusters that have the contents of the file? That's the data. All right, that points to the clusters and has the data runs that contain the contents of the file. All right, where are the timestamps for deleted files? You'll find them at least sometimes in the index. All right, and where are small files stored? That's resident data. Good. All right. So that's twisted, I think. And that's a 2-time winner, but I don't know who they are, but they've won twice. All right, the same 3 people win again. On we go. All right. So, good. We're not too late. We can carry on here. All right. There's a log file. Another one of those special files. And this logs all the transactions. This is a journaling file system. It's a big deal. Here's the USN journal. The journal is a big improvement of the NTFS file system. The old FAT file system did not have a journal, and that means if you had Windows 98 and it crashed, you would get this message during restart saying lost clusters found on the disk, and it would then hunt for them and try to restore them, and it was really a drag. The journal means that it keeps track of what it's doing. So if it's copying a file onto the disk, it writes down, I'm copying a file, I'm copying block 1, I'm copying block 2. So if it crashes or the power goes out, it can pick up where it left off and finish the activity. So it usually does not leave random junk on the disk. Windows 98 did, and it would take 5 minutes to fix it, and then it helped make these files in the root of C called file 000 and file 001 and so on, would be the leftover junk it found on the disk from incomplete file transfers. And that was fixed by switching to a journaling file system with this USN journal. All right. And volume shadow copies are very important. These came out with Windows 2000 Server, and they moved to every version of Windows now. Microsoft automatically makes backups of the entire file system It does that by only storing changes. So as you imagine, if your disk is 500 gigs, it can't store 500 gigs of extra data. What it does is it sets aside a portion of the disk, like 10 or 15%, and it makes shadow copies there and always deletes the old one to make room for the new one, but it's only storing the changes from the current state. So that's a much smaller file. And so with the shadow copy information, plus the existing live data, it can reconstruct the way the files were in the past. This started as a system restore function to roll the system files back in case you messed up the system in Windows 2000 server, but now it also applies to user data. You can roll your files back to the time they are in the past, which sounds wonderful, except if you delete a file, there's no way to roll back. It doesn't recover from that, and that is the most common mistake, of course. So it turns out not to be so incredibly useful, but it's good for forensic examiners. The VSS admin command can be used to control these shadow copies and to list them and find them. And then they have these long paths that exceed the maximum length, so you can use the make link command to create links pointing to them. And then you can open them in the command line. But of course, you can just use a tool like Velociraptor or any forensic suite, and it will automatically recover them for you. So it's a mirror of the entire file system at the time of the snapshot, and there's a variety of tools that have been around to do this, standalone special tools, but now it's included in forensic toolkits. And here's Velociraptor. You can open volume, VSS is volume shadow system. So you can just get the volume shadow copies here, and that's great. All right, yep, adjective, animal, and 2-digit number. Yeah, that's spooky. All right. And then there's a redirector. The redirector is how you can run 32-bit software on a 64-bit system. Now, the only thing you obviously need for that is you need 32-bit libraries, and that's the same thing on Linux. But what about the registry? If your 32-bit program tries to change a registry key, you don't want to mess up the 64-bit system. It might have different registry keys. So what it did is make a special registry zone that will change special registry keys in a WOW64 subfolder. And if you try to change things in System32, it really puts it in syswow64. So there are mirrored copies of system folders and registry keys for 32-bit applications. So they can write there, and when you run that application, it will look there and find what it expects, but the 64-bit applications will not find those altered things, so that modern code will not be wrecked by things old code did. So shadow copies are also good fun if you're a pen tester on a red team. Yes, of course, you can find passwords in them. Absolutely. Yep, all kinds of good stuff is left in there. I remember one year we did CPTC, and they forgot and left passwords in the history file in the Linux system. So everybody found the root password like in the first half hour, which made that year's contest a lot easier than they had intended for it to be. You can also copy ntds.dat that's locked while in use. Yes, that's right. Shadow copies, you can get files that are locked. Good. These are good tips. All right. So this means if you have a 32-bit tool, you're trying to scan the operating system, the 32-bit tool does not really see the whole system. It's sort of like a virtual machine. The 32-bit tool only sees the 32-bit copies of things, not the 64-bit stuff that are hidden from it. All right. And then there's Prefetch that we've already used quite a bit in the projects. Every time you launch any program, it puts a shortcut in the Prefetch folder, ending with a PF file extension. And that's so that next time you boot up, it can preload into memory the programs you appear to be using, so they'll launch faster. So the last 128 applications are stored there, not on Windows Server. Windows Server has this turned off because, of course, it's not intended to have somebody launching browsers and Office productivity suites and stuff. It's intended to be running one application, like a web server, a database server, and just letting it run. So this is only used on desktop versions of Windows unless you make a registry key adjustment to tell your server to act like a desktop. All right, and so even if the executable has been deleted, the old Prefetch entry will last for a while because it just keeps the last 128 things, and it'll last until you launch a bunch of new things to push it to the bottom. And it shows when it was run, how many times it was run, when it was first run. Gives you quite a lot of information. So there's a tool called Win Prefetch View that will let you see things like here's Firefox, and it shows you a lot of information about it. It even shows you, I guess, recently used documents in Firefox. But anyway, the main thing I know is it gives you this created time modified file size, exe, and such. Very handy. And you can get it, of course, in Velociraptor, which is what we've been doing. You can go here and you can see if a file has been launched recently, and if so, when. And I think also by whom. You even get the name of the person that launched it, the login name. Although I didn't see it here, I think it's available. All right. And let's see, records records about the executable. Yeah, you see the last 8 execution times and creation time, 9 potential executions. I think you also get the name of the user, but I'm not completely sure. All right. Then there's event logs. This is Microsoft's logging system, which sounds like it's great, but turns out not to be so great because for performance reasons, the default event logs are not very thorough. And they're also pretty clumsy to use. However, it does log a lot of things. And so learning how to use the logs is an important feature, for example, for tech support and also for forensic analysis. It'll record logins, start and stop of services, launch of applications, changes to the audit policy. The audit policy is a list of what kind of things it should be logged. And there's certain things logged by default, and you can tell it to log more things. Like you can audit a folder and say, I really care about this folder. I want a record of everybody that opens this folder. You can do that. That's an audit policy. It tracks user permissions, newly created accounts, and things like antivirus and web servers. So a lot of good information is in the Windows logs. The main logs are application, system, and security. Application logs has anything the application developer wanted to log. Antivirus and security products tend to make good logs. Other products might not make very many logs or no logs at all, depending on how the author wrote it. The system log is just events having to do with the Windows system that are not considered to be relevant to security, network configuration changes, loading drivers, and things like that. And here's where security-related events go, things like login and log-off attempts and changes to audit policy, things that are obviously of security importance. So you can get them. There's a registry key that specifies where the logs are stored, and it's here, C System32 Win Event Logs, and there's 3 EVTX files in there that contain the logs in a binary format, and you need a special tool to view them. So there they are, and you also have logs for the task scheduler, Windows Firewall. There's a lot of other things in the applications and services logs, terminal services, user access control. A lot of other services keep separate logs for them outside of those main 3. Each log entry has a source and an event ID number that uniquely identifies that type of event, and you can Google those. Just Googling event ID will often be extremely helpful for understanding a log entry. Microsoft's documentation of these things is very terrible. Maybe it's gotten better, but it was really terrible back in the days of Windows XP, and you got used to using third-party tools. There are whole places like eventid.net where system administrators just record what problems they had, what this log meant, and how they fixed it, and that is incredibly useful to maintain Windows systems. You go to the log, you find a problem, you go read up what other people did. That is how you really learn how to fix problems with Windows systems. All right. So here's a logon event, event ID 540. It tells you the name of the user. It tells you what type of login and a number. It tells you what process connected and what type of authentication, the name of the workstation it logged in, and its network address. So that's a really useful bit of information. This person connected from that laptop, and then you can decide whether that was really that person using a laptop or whether it's some kind of malware that infected that laptop, and that sort of thing. Here's what I got from a live Windows system. Earlier today, an account was successfully logged on. This is system logging on, so it's probably a background process, logon type 5. The ID is system. And here's the GUID, process ID, and so on. It's a service, services.exe logged in, and it logged on by ADV API was the process. So this is some kind of background service logging in as system to do something. It's one of those many services running in the background of Windows systems. So login ID is unique session identifier, and the type is a number here. So type 5 is remote interactive, type 3 is network, and so on. There's the various options here. And you got the process that initiated it, the package that was used to authenticate it, and the source system name and IP address, which is not always there, but when it's there, that's of course extremely helpful. So attackers often use stolen credentials. They'll get somebody to click on a link and install malware on one workstation. Then they'll steal the password hashes on that machine or the clear text passwords from RAM with Mimikatz. And then they'll have some credentials, and then they'll start authenticating to other things, trying to find the domain administrator credentials and the databases and stuff. So you'll see a lot of these remote login requests over the network as people do lateral movement, hacking into your system. So these login events are quite useful. So they got an example in the book where somebody hacks a Windows 7 machine. They get malware on this machine somehow. Now they run the backdoor on the domain user who owns Alpha, who owns that machine that he's on. And now they use password dumping and other things until they find a couple of other accounts here. They find a local admin and a domain admin. And so now they can move across. You can mount a share from... you mount a share on a workstation to host your malware, your hacking tools. Then you use ps-exec to launch processes on other machines, which will upload the malware to them, and then you do make a remote desktop connection to them and so on. This is what you do. You wander around the network using the various remote control protocols to control this system and control that system, put files here, run processes there, and all those things will create login events as requests go over the network to authenticate on these systems to do those activities. So here's a login type 3 from a local account. Then this one, login type 10, remote interactive, another login type 3. You know, that's the sort of thing. So if you change the settings, like create a new user account or elevate a user to administrator or anything, that will of course be logged. Policy changings will matter, like for example, if you turn off logging or delete the logs, it will record that. An event showing the audit log was cleared is recorded when you delete the logs. That's why deleting the logs, and in default Windows, you just go to Event Viewer, right-click on logs and delete them. But that is kind of an amateur thing to do because then it creates a log entry saying the log was deleted. If you use a hacking tool like Metasploit to delete the logs, then it nukes the logs without creating an entry showing you nuked the logs, which is a little cleaner. All right, so you can audit processes if you want, and this will put an entry in the security log every time a process is executed or terminated. A better way to do this is use sysmon, which we've been using in the projects, but you can do it with the process auditing option in Windows. And service, whenever services start or stop, that's recorded, and as you know, you can often run malware as a service, and then you can find it there. So here's some, if you use ps-exec, you'll see a ps-exec service started, and then it stopped. So this is what happens when you use the ps-exec utility to remotely run a process on another box. So here's suspicious things. People using ps-exec if they shouldn't be. Most people don't normally use it. Known bad service names, or another thing is you might have errors when services try to start, but the binary is gone. That's an unusual bad thing that might easily happen from a hacker installing some kind of hacking tool and then deleting it and not realizing that tool runs as a service, not cleaning out the service as well. It's the kind of mistake you might easily make, and then you'd leave that kind of trail behind. So check the application log for an antivirus alert. Logs are not kept very long on Windows systems. You should increase the log size, or, much better, exfiltrate the logs to an aggregation engine like Splunk. There is a tool to fix the old binary format of logs that often got corrupt. I don't know if that matters anymore. Probably not unless you have old systems like XP. And here's a lot of tools. Event Viewer is the main tool that built into Windows you use, but there's a lot of other tools that can explore these. But of course, for us, it's Velociraptor. Velociraptor is awesome, and you've already done this in the projects. You can install sysmon on the system, and then you can just harvest the event logs. With Windows event logs, you can see all these logs, the default logs and the sysmon logs. Is that something of a danger in terms of visibility when using it as an attacker, that they'll be recognized and logged? Well, I think it is, yes. It is somewhat suspicious to use them, but the main thing about them is they will not trigger antivirus alerts. They are authenticated Windows products, but they're not used in the normal course of events. So it's a good question. You know, if I had the option in like an antivirus product to flag sysinternals tools, I might do that. It's an interesting issue. Yeah, context might be the key, but you know, at my company, you know, the fact is your legitimate system administrators are probably using these tools. They turn out to be quite helpful, so I guess you can't always flag them, but they're not something an end user should be using. However, your system administrator might very well be using them and configuring them to automatically run and do things. So they certainly won't trigger antivirus alerts or anything. They're legitimate Windows system maintenance tools. And then there's scheduled tasks. This is the equivalent of cron jobs in Linux. You just specify at a certain time, do something. So at this time, run this program. That'll run this program next time the clock hits that point. You can also do every Monday, Tuesday, and Wednesday, and so on. So you can do it from the command line with the @ command. And you can use the scheduled task command to configure all the properties, and you can use the GUI, Microsoft Scheduled Tasks, to create these things, and then they will run at scheduled times, and this is commonly done by malware for persistence. The way it works is when you create a scheduled task, it creates a job file in system root tasks, and that file persists until shutdown or reboot. And then after reboot, the scheduled task recreates those job files. So there are logs kept, start time and completion of tasks, and it also creates event logs in the operational log and in the security log as tasks start and stop. You can open the job file. It's a binary file. You need a special tool to analyze it in detail, but if job file parser is available, and you can see some of the strings even without using a tool. But if you use a proper tool like this job parser, then it will show you the maximum runtime is 3 days, which I think is the default. Don't start if on batteries. Task has not yet run, and so on. You know, just the information you might expect. All right, and here's the scheduled task log showing the scheduler service started, then AT2 job started, then the schedule it finished, then some other agent resumed a task. You know, that's what it is. You have a log of just all the tasks starting and stopping. And if they create errors, there'll be logs there too, I imagine. And here's Event Viewer showing this user registered a task scheduler task AT1, and then they launched an instance of AT1 due to a time trigger condition. So that's why it's this time 10:05. It hit the time, it launched it, and on you go, just recording what it did. It successfully completed this task, and on you go. All right. And of course, you can get all that stuff in Velociraptor. You can get task schedule, and it'll give you the information about the scheduled tasks. I think it just runs the SCH task command at the other end and sends you the results, which is what most of these Velociraptor's tools do. They just run a simple command line command at the other end. The only cool thing is it's a nice central point of administration to manage all your devices. All right. And this nice explanation here means you don't really have to memorize all the details. You can hunt for something and then read this explanation to decide whether it's going to help you. So it's sort of like, you know, having a textbook, an open book test. You don't have to memorize all the details of these things. You just have to remember enough about them to find them in this list, which is very nice. All right. So we got the last Kahoot, which is 12A3, which is here. That's twisted. Genius Bear 27. There might be a lot of fun meta commands for Kahoot. Oh, I think there's one more user, but maybe they're not coming in. All right, we are proceeding then. All right, the complete copy of the whole volume. That's the shadow copy. All right. All right. What prevents a 32-bit app from messing up a 64-bit system? The redirector causes the 32-bit app to not really change the active values of important things, but to only change special copies of those things used only by 32-bit apps. All right. And where are the login attempts? Yep, they're in security events. Not system, but security. All right. Which one has one instance per task? Each scheduled task has a job file. schtasks is just the command to administer them. There's a separate job file for each scheduled task, just like there's a separate PF file for each entry in the Prefetch folder. All right, and which one of these persists until reboot? The job files are erased on reboot and then recreated by the task scheduler. All right. All right. It's Clayton. Ah, new winner. Aha. All right. Good. So I've got the winners, although 0-0, I don't know who they are, but the other people I know who they are, so they will get their points anyway. Let me stop the recording.